anybody, if anybody has ever seen, if anybody has ever seen me get frustrated with technology during class, here's a perfect example. Um, I'm back. I hate the internet. Absolutely crazy. I'm so sorry about that. I'm gonna try to get as much as I can here. Evidently at 8 something in the morning that the Spectrum decides to just, throttle, you know, throttle data and all that kind of good stuff. If anybody knows that terminology, yes, I see, I see you guys. Hello, hello. I'm sorry about that, guys. That's just I can't do anything about the internet other than upgrade, I guess, or something. Um, since that just threw me all the way off, I want to try to get as much as possible here in these last little bits. I'm just going to go straight. I'm just going to go straight to the packet here and try to just kind of go over pretty quickly here. Um, if you look at this, if you look at 6.1, if you look at 6.1, again, this is just. I'm going to try to get through 6.1, 6.2, and 6.3 in this, and then hopefully tomorrow my internet won't decide to crap out like that. So my apologies on that. Oh my, that's ridiculous. Usually, like, if anybody knows anything about, internet, usually like peak times, like, if you live like I live there's townhouses around here where I'm at, and usually there's, like peak time when you have a lot of people around you, peak time, like you're 7 o'clock, 8 o'clock, or when everybody's usually home, that's when usually, internet will slow down because there's so many people doing this. It's 8 something in the morning. That doesn't make any sense. And I paid the bill, so it's okay. But um, yes, that's a great way to start out the start out the morning here. And again, guys, I'm apologize about that. So let me just get through. I'm just going to kind of just get through this here. So you have 6.1. We're talking about representing percentages. I'm going to try to take this into more of a thing here. By the way, if those of you pop back into this stream, let me know who's on here. I see Dimitri's on here. There's a couple more people, but just let me know who's on here, just so I can, so I know who I'm talking to. I know Dimitri, or I know David and Lucas were on too. Just kind of let me know you're back here too. If not, then we'll just deal with it. But um, again, percent rate compares a part to 100. The word percent means of 100. If you ever wondered why percent means what it is, there it is, right there. It explains it to you right there. Okay. We talk about representing percentages. So if you say like, well, what's the percent of each figure that is shaded? So the percent of the figure that is shaded right here. If you look at this, this is your base 100. There are 100 blocks on here. There are 100 blocks on this. So when there's 100 blocks on this, how many of those are colored in? Well, if you look at this, if you look at this and you look at what's colored in, look at what's colored in right here. There's two base tens, two base tens, and then an extra one. So that would be 21%. So that would be 21% of the figure that is shaded in. Hi, David. Hi, David. Sorry again. Sorry about that. Internet doesn't want to do me very wonders on this. Again, that first one is 21%. 21%. And what I was starting to try to get into was number two here, where now this is a reduced part. So if you say, well, like how many of the 10 are colored in? It's 7. It's 7 out of 10. But to make it based off of a base of 100, because remember, percent is based on of 100, you can set up an equivalent ratio here. 10 times your 10 will give you 100. What you do to the bottom, you do to the top. So you know that it would be 70. So 70%, 70% of that figure is shaded. 70% of that figure is shaded. So number one's 21, number two is 70. 7 of the 10. Okay, so 7 of the 10. All right. We look at number three. You say, well, write each ratio as a percent. Write each ratio as a percent. Out of a total of 50 games, so the whole is 50 games, there were 14 losses. So in what I was again about to get into, if you have 14 losses out of 50 games, 14 losses out of 50 games, right there. Again, if you want to relate that fraction that you have as a whole, or as out of 100, you want to create an equivalent ratio here. So 50 times 2 equals 100, which you do to the bottom, you do to the top. So as a percent, it is 28% for number 3. Okay, I'm moving quick with this, but again, you can always go back and look at this specific stream. What I'm going to do is I'm going to delete that other stream once done. That was just, it was ridiculous. So number 4, 4/5 of the students ride a bus. So 4/5 of the students ride a bus. So the way I can take 4/5. Let me get rid of some of this other gobbledygook right here. Okay. So if you look at this, what's up, Deshaun? What's up, man? So if you take 4 over 5, and you want to make your equivalent ratio, remember percent is made out of 100. So you take 5 times what equals 100? 5 times 20 equals 100, which you do to the bottom, you do to the top. So 20 times 4 is going to be 80. So when they ask what's the ratio as a percent, 80% out of that 100 will be the ones that ride the bus. So number 5, if AB represents 25%, what is the length of a line segment that is 100%? So you look at this and you say, if that's 25%, how many 25% go into 100%? Now it's weird to say it like that, but what is 25 plus 25 plus 25 plus 25? And that's 100. There are 4 of those. There are 4. And again, this is stuff that I was getting into before Spectrum, went cuckoo on me. So if this represents 25%, and we know that there are 4 of these that are 100, you can take that 5 times 4 and gives you 20 feet. So 20 feet right there. And here are your answers right there. I initially did not want to do this, but thanks, Spectrum. Okay, I'm going to move down here, try to get as much as possible here. Good grief. What I might do tomorrow is go on slightly earlier just to get some more of that information here. Possibly. We'll see. Yeah, because I want to talk about all this tomorrow. Just know that with 6.2 and 6.3, so if we were to change a decimal to a percent, or a fraction or anything of that sort, I'll go through this more tomorrow, but if you had a decimal which was 0.16, and I wanted to change that decimal to a percent, so to a percent, the easy way is taking the decimal and just moving it 2 to the right. When you move it 2 to the right, you now know that it is 16%. Then if you take that 0.16 and make it as a fraction, I always say when you take a decimal to verbalize it. So if you verbalize it and you say that is 16 hundredths. I'm going to try to write this out. 16 hundredths. Okay. Hundredths. It's a smaller piece. So 16 hundredths. That's the way you can remember it that way. Okay. I'll talk more about this tomorrow. Luke, yeah. Let's see. Hi, Lucas. Hello. So, again, 16 hundredths with this. So the 3 ways you're doing this, just remember the 2 other forms of notation: fraction, fraction, decimal, or percent. If I'm taking 16 and moving it to a percent, I'm just moving it 2 to the right. 2 to the right when I'm going from decimal to percent. Well, if you're looking at maybe decimal to percent. Okay, so in this instance, number 2, let me change. So like number 2 right here. if I have 63 over 100 or 63 hundredths, think of it that way. Think of the verbalization of it. And I said that a lot during, when we're, during class, like verbalize it, and say 63 hundredths, 63 hundredths, and then if you change that decimal to a percent, you're moving that point to the right, which will make it 63%. I want to move slightly quick here, and then I want to make way for seventh grade, but I'll try to like get on a little earlier tomorrow to cover the missing stuff. But again, it'll be on for like an on-demand purpose there too. Um, I think that's maybe what I'll do. That's what I'll do too. Yeah, talking out loud. Let me do one more here. Number three. So number three, if you have 27%, 27%. Now here's the difference. Your decimal is here, right? Because if we went from decimal to percent, it's two to the right. Well, percent to decimal, it's two to the left. Two to the left. 27% as a decimal is 0.27. 27 hundredths is 27 over 100. Guys, I will go more into this. I will go more into this tomorrow. It's possible I might do a on-demand video after I'm done with eighth grade today, just to kind of suffice for the missing information here. Again, I apologize about the internet, but I don't control the internet. So I'm gonna let me type my email here in the chat one more time here. If you have any questions with anything, please send me an email. Or you guys always, or you guys also have your Google Classroom, to to write questions and all that kind of good stuff. Any of you who are with me here, seventh grade, I'm going to create a new stream for seventh grade just so that it's separate. But I think I'm going to make a slightly an on-demand video for that missing little 10 minutes there that we had there. Again, apologize about that, but we'll talk more about percents. Topic 6, again, I know this is a little bit of a mess, but apologize about that. All right, so I hope you guys have a good day. Take care.